So what if an AI could do more than just, solve problems it's already seen? What if it could actually learn how to make genuine scientific breakthroughs all by itself? Well, we're about to explore a brand new method that's doing exactly that, and it's achieving world-class results in everything from pure mathematics to super advanced computer engineering.
I want you to think back to the hardest assignment you ever had in school. You know the one, where reading the textbook just wasn't going to cut it. You had to try something, fail, learn from what went wrong, and slowly, piece by piece, build up an intuition for the answer. You basically had to learn something fundamentally new just to solve that one single problem. Well, it turns out AI faces the exact same scenario. It's called an out-of-distribution problem. And it's just a fancy way of saying it's a situation that is completely different from anything the AI has ever seen in its training data. And if you think about it, a real scientific discovery is the ultimate out-of-distribution problem, right? I mean, you can't train an AI on data that literally doesn't exist yet. So how have we tried to get AIs to tackle these problems in the past? Well, for the most part, we've just had them guess. A lot. But as we're about to see, that whole approach has a really fundamental flaw. Okay, so on the left, you've got the old way, a frozen AI. Its knowledge is totally fixed. It can't learn anything new. So all it can do is guess and search, hoping a clever prompt eventually works. It's kind of like a student who just copies someone else's notes without ever actually learning the material. But the new way? Totally different. The AI itself actually learns on the job. It uses its own attempts as fresh training data. It actually internalizes the new ideas, like a student who really gets it. And this really gets to the heart of the problem. The researchers behind this new method put it perfectly. With that old approach, the AI model itself just cannot improve. It's stuck. It never truly understands the new problem it's trying to solve. And that brings us to the breakthrough, a brand new method designed specifically for discovery, and it's called Test Time Training to Discover. Okay, so the name sounds a little technical, but the key idea is right there. Instead of having a fixed pre-trained model, TTT-Discover keeps training itself at test time, meaning while it's actively working on the problem. Its own attempts, the good ones and the bad ones, become the perfect custom-made training dataset for that specific discovery. So it works in this really simple but powerful loop. First, the AI makes an attempt. Then, it gets a score based on how well it did. It then uses that experience to update its own internal knowledge. And then it tries again, but this time it's a little bit smarter. It does this over and over and over, creating this amazing feedback loop where it just continuously improves. So how does it actually learn so well? I mean, this isn't just random trial and error. It's all about having a brilliant strategy. And it really comes down to two key ingredients: the secret sauce. First up is its goal. See, most AI training is about getting good, average performance, like aiming for a solid B on every single test. But TT-Discover doesn't care about the average. When you're trying to make a discovery, you only need one breakthrough solution. So its learning is laser-focused on finding that single best possible answer, that A+. It aggressively chases after the most promising attempts. And second is how it explores its options. It uses this really clever technique to constantly revisit its past attempts. You can think of it like a chess grandmaster reviewing old games. It doesn't just look at the wins. It might go back to a failed attempt that had a little spark of a good idea, one brilliant move in a lost match, and try to build a whole new strategy from just that spark. This lets it perfectly balance exploiting what works with exploring totally new paths. Okay, the theory is super impressive, but does it actually work in practice? Let's take a look at what happened when they put this AI to the test, because honestly, the results are incredible. The researchers tested TTT-Discover on a whole range of tough problems. And just look at this. It set new state-of-the-art records in almost all of them. We're talking a classic problem in mathematics, optimizing super complex GPU code, outperforming human experts in algorithm design competitions, and even improving analysis in biology. It's a real polymath. Let's zoom in on the GPU engineering for a second. This chart shows the speed of a kernel. That's a really critical piece of code that runs on the GPU. On a newer H100 GPU, the best human expert got the code to run in 1,371 microseconds. TT-Discover's solution? A blazing fast 1,161 microseconds. That is a huge leap in a field where every tiny fraction of a second matters. And get this, on a slightly older GPU, the A100, the result was even more dramatic. The AI solution was more than twice as fast as the best code written by a human. And this wasn't some kind of fluke or a cheat. The competition organizers themselves reviewed the AI's code and confirmed how good it was. They said the AI used strategies similar to what human experts do, but it just executed them better by fusing together complex operations in a more effective way.
Now, let's look at the math problem. This is the famous Erdos minimum overlap problem, where the goal is to find the lowest possible number. TTT-Discover found a new best ever answer. And what's really wild is that its improvement over the last AI was 16 times larger than that AI's improvement over the previous human record. It wasn't a small step, it was a giant leap.
And again, this result was double-checked and validated by an expert in the field. He confirmed that, yep, the AI's solution undeniably improves upon the state-of-the-art. This is a real, verifiable mathematical discovery made by an AI. So, what does all this mean? This is way more than just a handful of cool results. It really points to a completely new future for how we approach discovery itself. But maybe the most shocking number of all is this one, the cost. You might be thinking this took a supercomputer weeks to run. Nope. To achieve each one of these state-of-the-art world record breakthroughs took only about $500 of compute time. Just $500. So let's just step back and break down why this matters so much. First, this is a whole new paradigm. Instead of just using AI as a search tool, we have an AI that learns and discovers right alongside us. And what's so crucial is that this was all done with an open model, not some giant closed-off frontier model. That makes this kind of cutting-edge research incredibly accessible to almost anyone. The fundamental takeaway here is that the AI isn't just finding answers from its memory. It is learning the process of finding them. And that leaves us with this one incredible, kind of mind-bending thought. If a state-of-the-art mathematical proof or a revolutionary piece of code is now this accessible, if it costs less than a new phone, that fundamentally changes the game. So the only real question left is, what problem should we give it next?